In this paper, we have designed the compact 4-port MIMO Antenna-Diplexer utilizing the slotted HMSIW technology. In recent years, multiband antennas have been widely utilized in compact handheld and mobile wireless communication systems. Diplexer elements are developed to ensure adequate isolation between transceiver systems. Improving the channel capacity is important for making wireless communication work better. To address these challenges, this work presents a novel and compact 2x2 MIMO self-duplexing antenna based on half-mode substrate integrated waveguide technology. Figure 1 shows the proposed 4-port 2x2 MIMO antenna. The SAW cavity is constructed using the chains of metallic vias which act as a lateral walls. These vias forms the metallic boundaries in the SAW. Initially, a full mode SAW cavity is designed that is operating at 5.2 GHz. Two HMSIW cavities resonating at 4.9 GHz and 5.8 GHz. By placing the rectangular slot along the center of the cavity, 50% of bandwidth is excited. When port 1 is excited, T110 mode split into even and odd modes. When port 2 is excited, odd even modes of cavity 2 resonates at 5.7 GHz and 5.85 GHz. By placing the two cavities at different sizes orthogonally, high isolation is achieved, that is shown in figure 3. These configurations suppress the fields at identical frequencies, achieving the dips in the S13 and S24 plots, that is shown in the figure 4. Figure 5 shows the S parameters versus frequency with the length of the slot changes. If the length of the slot increases, it leads to the downward shift in the resonant frequencies and affecting the impedance matching. If the slot position changes, it influences the mode coupling in both lower and upper frequency bands, that is shown in the figure 6. If the gap between the cavities increases, it alters the mode coupling and leading to the enhanced bandwidth, that is shown in figure A. If the cavity size is increased, it results in a downward frequency shift due to the enlarged effective aperture. 4 MIMO diversity matrices are derived. One is the ECC. ECC value is less than 0.05 is achieved for lower frequency band. 9.8 dB diversity gain is achieved. For upper frequency band, 9.6 dB diversity gain is obtained. TARC less than minus 12 dB is achieved, and CCL is less than 0.1 bits per second for Hz is achieved across both the frequency bands. Figure 10 shows the fabricated photographs of fabricated prototype, front view, back view, and figure C shows the S parameters versus frequency. The proposed antenna exhibits a stable bandwidth, port 1 having the bandwidth of 150 MHz and port 2 achieved the bandwidth of 250 MHz. Figure D shows the simulated and measured copole or crosspole radiation patterns at port 1 and port 2. These radiation patterns remain stable and unidirectional across all the planes with a front to back ratio exceeding 10 dB in both the bands. Conclusion: this paper presents the compact 4-port self-duplexing MIMO antenna designed for wireless LAN and ISM band frequencies. By using the HMSIW technology, 50% of size reduction is achieved. Radiating elements are placed out of phase, effectively cancel the field coupling, so it can result in the isolation is exceeding 30 dB. This design shows the MIMO performance matrices including ECC, MEG, CCL and TARCR within satisfactory limits.